We treat mathematics like a foreign language composed entirely of invisible rules. For many students, it's an intimidating system of abstract symbols demanding perfect recall. When a teacher writes an equation on a chalkboard, they are introducing an abstraction. For a young mind that hasn't physically experienced the logic behind those numbers, that chalkboard is a cognitive vacuum. Without a concrete foundation to anchor to, students are forced to rely on rote memorization to survive tests. The result is intense anxiety and a rapid loss of information the moment the exam is over. A system built entirely on short-term recall doesn't teach a child how to solve problems. It only teaches them how to mimic solutions. Fixing this requires a change in how the brain acquires knowledge. It's a pedagogical framework known as constructivism. The core premise is straightforward. Children cannot passively absorb information. They have to actively construct it. And to physically build a concept, you need physical tools. The action has to move off the chalkboard and directly onto the student's desk. This is where the Ganitha Kalika Andalana methodology steps in. It replaces abstract chalk dust with a kit of 25 distinct teaching and learning materials. You have Unifix cubes for arithmetic, geoboards for spatial reasoning, and physical pie pieces for fractions. These components provide tactile, calibrated evidence for mathematical properties, moving the student's focus from visual memory toward physical logic. Facilitators use the 5E instructional model, starting with the engage stage. Instead of a formula, they present a puzzle to spark curiosity. Next is the explore stage, the concrete phase, where the facilitator physically hands the problem to the students. Rather than watching someone else do the math, students manipulate these shapes themselves. They collaborate, test boundaries, and discover the underlying patterns on their own. The teacher steps back, allowing the physical logic to take the lead. Because the numbers are things you can actually hold, the intimidation factor disappears. The complex concept is grounded in an undeniable physical reality. With the physical foundation built, the facilitator steps back in for the explain stage. This is the crucial bridge connecting what the students just touched to the actual language of mathematics. This is the representational phase. We are translating three-dimensional actions into two-dimensional symbols. This chart shows exactly how it works. By arranging physical blue and yellow blocks into rows and columns, the manual demonstrates the area model of multiplication and how separating those same blocks represents division. The student sees 12 individual items. They physically group them into 3 distinct sets of 4. Only then do they write down the numbers that describe what they just did. 12 divided by 3 equals 4. The facilitator doesn't need to force memorization. They simply act as a translator, decoding the logic the student has already proven to themselves. Now the class enters the elaborate stage, moving into the purely abstract phase. The physical blocks are put away. Students take the conceptual logic they just internalized and apply it to a new problem using only numbers. For example, after using rubber bands on a geoboard to physically build acute and obtuse angles, they can now identify those same relationships in a purely theoretical diagram. Successfully making this leap from the physical to the abstract proves that the core concept has actually taken root in the mind. The student now treats the equation as a verifiable law, having personally experienced the proof behind the symbol. The final step in the model is the evaluate phase. But in this framework, evaluation isn't a stressful exam at the end of the year. It operates on the principle of continuous and comprehensive evaluation. Instead of waiting weeks to grade a written test, a facilitator can instantly see if a student understands a concept simply by watching how they arrange the blocks on their desk. This turns testing from a high-stakes event into an ongoing, low-stress dialogue between the guide and the learner. On a macro level, this is exactly what the National Education Policy 2020 aims to achieve. The GKA 2.0 framework redesigns the entire ecosystem of the classroom. This shift positions the facilitator as a guide through discovery, where students carry the cognitive load of building their own logical frameworks. Fragmented, intimidating numbers are physically connected, step by step, until they form a cohesive, rock-solid foundation of understanding. This methodology replaces the source of math anxiety with a joyful, foundational literacy that lasts a lifetime.